Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 12th. Looking at significant wave heights for the South Pacific Ocean, we see a storm with near 50-foot seas right on the edge of the Southern California swell window. Most of this energy pushing towards Chile and Peru, but you also see a good, fair-sized patch of seas pushing north associated with a second swell. There's actually swell in the water right now hitting Southern California and Hawaii, and a second swell also pushing in that direction. So, one swell in the water, a second swell on the way, and maybe bits of energy from a third swell developing. Not a bad pattern. All right, let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough, and in the southern hemisphere, that is a patch of winds in the jet stream pushing north. That helps create a clockwise flow aloft and down at the surface, and that, in the southern hemisphere, is the sign of low pressure. And of course, low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. So we have a bit of a trough. You look at it, doesn't look like much. There's like no real winds associated with it over here. There is 140 knot winds over the southwest Pacific, and they're actually falling south. That's a ridge. It's pushing south. That actually helps support high pressure development. But here, nothing super apparent, but apparently there is a storm there because we have significant seas in this area. All right, we'll get into the details. Anyway, so as we get into Sunday night and Monday, yeah, that looks a lot more like a trough. There's decent winds pushing into it. So it almost seems like the model's sort of lagging behind a little bit of what's happening in reality. Anyway, the point is this trough is going to be pushing out of the Southern California swell window. There we are as we get into Monday night. Pretty solid trough, but all aimed at Peru, Chile. Southern California ends about 117 west, somewhere in there, and this trough will be out of there. That means the associated low pressure associated with it will be gone as well. All right, ridge persists over the West Pacific into the Central Pacific, but it almost looks like a new trough starting to build, not in the Southwest Pacific yet as we get into Tuesday, but maybe by Tuesday night, Wednesday, there's a bit of a trough, not super strong, but hey, that other trough that's building significant seas right now doesn't look like much. Then we get into Wednesday, what's that, 140 knot winds feeding the trough. And that sort of continues on into Thursday, reinforced into Friday. You know, it kind of looks like something. There's a ridge building the Southeast Pacific. Here comes more energy building into Friday night and Saturday. Actually, that looks like a very nice trough a week from now under New Zealand, pushing into the Southwest Pacific into Sunday. And here we are at 180 hours. That looks pretty good. We'll see what the surface level models and the wave models have to say about that, though. What happens in the upper atmosphere doesn't always translate down to the surface, but it's a good indicator. So here we are at the surface level pressure, surface level winds. We see low pressure over New Zealand. Any fetch associated, 35 knot fetch, that sort of tannish color right there, 35 to 40 knots, is all pushing south at Antarctica, so no good for swell development. But of course, the thing that jumps out, 50 knot winds right here on the eastern edge of the Southern California and Northern California swell window, obviously generating seas, but as we get into 12 hours from now, it's out of the Southern California swell window, targeting Patagonia, Chile, that area. This system here, not doing much. It's falling south. Now look at that, 55 knot winds. This is going to be an interesting one. So we're talking Monday morning, midday Monday morning, 55 knot winds aim north, but the fetch itself is falling south. So these sort of situations typically don't generate much swell, and you can see I'll tell you what, we'll just play this out. Boom, boom, boom. Okay, now let's roll back and watch you really want the fetch to be pushing, not only aimed northeast, but also pushing that way. Instead, it falls from here, down, 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 down. So it looks impressive. We don't think much swell is going to originate from it. Then we get into Wednesday or so when that new trough starts building under New Zealand. Yeah, we got a patch of 35 knot winds, 40, maybe 45, but not super well organized. Maybe good for background swell, we'll say. But, you know, from that distance, that's 6,500 nautical miles away from California. Hawaii certainly will get swell from it. And this is a good position for California, too. Certainly northern California, that, you know, sort of prime 210-plus degree direction. But you need a good 40 to 45 knot fetch of winds to make a long enough period to get you like 17, 18-second periods to make the whole trip without decaying into nothing at all. So then here we go. We get into Saturday. Here comes another patch of 45 knot, almost 50 knot. This one looks much better. Of course, it's a week out. Don't believe that. But actually, decent winds and lifting to the northeast. If you believe the models, this has promise. So, and this is kind of new on the models. We had kind of thought, well, things are going to mellow out for a while, but now it looks like maybe a week from now, we could be back in the situation of swell being generated. Let's go take a look at the wave models, see what effect these winds will have on the ocean surface. So first up, we're going back in time, all right? So there's a system in the southeast Pacific. It actually started in the central South Pacific, but this is a week ago. This is the system that has generated swell that is currently hitting California. Nothing huge, you know, there are some, maybe head-high waves, you know, at some of it, maybe a little bit bigger at top spots, but nothing huge. Second system developed behind it. This is the one that's going to be swell from this is going to radiate into California next week. And see, we got a good area of 42-foot seas. Now, most of this was shadowed relative to Tahiti, relative to Northern California, but not so much for Southern California. It lifted gently northeast, and while pushing out of the swell shadow, still with decent, you know, I think it was right about here. It had, 36, maybe 37-foot seas and unshadowed, and then it faded out. That's certainly good for swell pretty much all of next week. Then we go into this sort of pattern where there's just nothing going on, and that's what's been the case. You know, right now we're into Friday, like 2 days ago, and continuing into Saturday. Now here's the developing system that we're looking at right now, and it had 42-foot, 43-foot seas this morning, and then 49-foot seas as of, 6 hours ago, something like that, and in both the North and Southern California swell window. But the deal is, it's not pushing up to the north, it's pushing pretty much, well, just look at the direction, pretty much due east. So the thought is not a whole, but given the magnitude of the seas, sure, some sort of swell, very south angled, is going to be radiating north into California, but probably not epic in terms of size. And then we move out looking into the future. All right, we're at 10 o'clock tonight, California time, 11 o'clock. This system's out of the California swell window. Then we had that system that developed well southeast of New Zealand, but it was falling southeast. Remember that? And you can see, yeah, good sized seas. Again, 48, 49-foot seas, but there, we'll just put this back here. You see they're tracking this way instead of this way. So the thought is probably not any swell of any magnitude to result for California from that. But the good news is, now I'm going back again. Here we go. Tuesday night, system sneaks just under New Zealand with 36-foot seas, something like that. So that's good for a little pulse of swell, certainly for Hawaii and certainly for Tahiti. I mean, we're not even going to talk about that. They'll get plenty of swell. For California, maybe not so much. Then a secondary system developed below is supposed to develop below on Saturday. So we're talking almost a week out. Is that believable? Probably not, with up to near 39, 40-foot, 42-foot seas, something like that. I mean, this would be kind of nice because it is pushing to the northeast, pretty intense, not over a large area, but holds together for a pretty good duration, and possibly not shadowed relative to Northern California, but we'll have to go do the fine detail inspection. A little too close to go do that now. Anyway, so the short of it, looks like there's potential swell. It's not over yet. Yeah, swell will back off for a bit here because for maybe a week after this next incoming run of swell. But then behind that, possibly more. Not a bad pattern for early in the season. And then we look at the North Pacific, and you go say, why are we looking at the North Pacific? Because the models are teasing and just luring us into this, suckering us into believing that something might happen in the Gulf of Alaska. 18Z on Thursday, that's what, 4 or 5 days from now? Look at this. Small little system. This has been on and off the charts. It's been doing it for 2 or 3 days now. What is that, 23-foot seas, 25-foot seas off of Northern California on Thursday night, and then fading while moving right towards the coast. Could there possibly be some swell from this? We're going to say probably not a chance, but we'll watch it just the same. I mean, southern hemi swell, if it fades out, this is a week from now, it'd be nice to see some north swell if we could get it, or northwest swell. But we're not expecting. Look at all this. There's like, it's teasing like mad, but it's May 12th. You think it's going to happen? I don't. Anyway, we'll see. All right, a quick look at, let's see if there's potential for wind swell too, or preferably not, especially with incoming southern hemi swell. So let's see. Low pressure in the Gulf, that's good. That knocks down. So typically our wind swell for Hawaii and for California is generated by strong high pressure that's normally in place this time of year, and that generates north winds down the California coast and east trades into the Hawaiian Islands. But I see 2 low pressure systems right here. That means high pressure weak. That probably means no wind swell. We're into Tuesday. We're watching that. No. Looking for some gradient or something to happen here. We're into Thursday, and no. And then here comes the new low pressure system with 35 knot winds, 40 knot winds. That does not buying it for a second. But the short of it, no real wind swell indicated. We'll roll this out. The low supposedly pulling right into Northern California on Friday night and Saturday, dissipating with a secondary low behind it. If that happens, there would certainly be swell of some kind, which would be nice to fill in the gap, and then maybe a third one behind that. Just doesn't seem reasonable. There's your high pressure trying to build as we get into like Sunday, Monday. Trades picking up along the east shores of the Hawaiian Islands. Maybe good for some wind swell on east-facing spots. So multiple teasers here, both north and south. All right, so if we're going to get suckered into believing that there's going to be swell in the Gulf of Alaska and a cold front approaching the coast, we might as well take a look and see if there's going to be any rain or what sort of weather impacts that'll have into California. And supposedly by Tuesday, rain in Northern California, not really making it to, almost making it to San Francisco on Wednesday, but not quite. Sierras, for the most part, pretty dry. And then something moves in on Thursday. Rain from, we'll say, Santa Barbara northward. Snow in the higher elevations of the Central Sierra. Up into Tahoe, perhaps. Really? Possibly. Short-lived. By Friday, that one fades. Here comes the next system. Friday afternoon with rain almost down to down to San Francisco, maybe even to Monterey Bay. Snow for the higher elevations of the Sierra. That tries to fade Saturday and then gets reinforced with snow over the entire Sierra Saturday night, then fading on Sunday morning, but then being reinforced again. This, and look at that, 180 hours out, like a full winter bombing snowstorm over the Sierra, seems not possible at all, but something to look at. Well, okay, if we're going to go that far, let's go look at the snow forecast. Here's the snow dashboard for Squaw Valley, and supposedly it's all attributable to that last big dump of snow. 2 feet of snow? No, even a foot of snow, 6 inches to a foot of snow to 14 inches over the next week. If we just completely ignore the big dump, that doesn't seem really possible, but okay. And snow levels, well, so this is the top of Squaw Valley, like 8,900 feet, top of Granite Chief if you hike the peak. This is down at the valley floor. If it's red, it's all liquid precipitation. And then supposedly, as you get into this, it's almost snow or at least sleet. The gray is sleet the whole way down to the bottom of Squaw over that run when all that weather comes in. How are the winds doing? Building winds too, 40 knots. Seems a little fantastical, but maybe. Let's go take a look at the Southern Sierra. Here's Mammoth. Okay, we're talking 8 inches, maybe 10 inches. Yeah, and this time of year, that's kind of, and mainly attributed to their higher elevation, 8,000 feet at the base, and all snow, but not nearly as much of it. I guess we'll see. This is one of these things where you keep watching, and as it gets closer and closer, typically the models just start falling apart. This seems like a bunch of hype at this point in time. Not believing any of it, but you never know. It would be kind of interesting if it did happen. We'll watch the models and see. So let's go take a look long term. And one, let's see what's going to happen with the MJO. And we know the MJO, when in the active state, helps fuel storm development, both in the North Pacific in winter months and the South Pacific in summer months. So the correlation is stronger in the North Pacific in the winter. And of course, El Nino, which it is there. Not particularly strong, but we are in a weak El Nino pattern. And let's also examine whether the MJO might be feeding that kind of wet, stormy North Pacific pattern that the models are hinting at a week out. All right, let's go. So as usual, we'll start looking at winds on the equator from the TAO buoy array, a series of buoys strung across the equator. This line here is the equator. This is the East Pacific here. Think like, the Galapagos Islands over here. That is New Guinea there, so you're in the far West Pacific there. The date line's right there. The good news is we had a big major data drop out here a couple days ago, but it's back. That's good news. So actual winds, 5-day average winds from the east, pretty much over the entire eastern Pacific. That would be what you'd call trades. But then as you get to the date line, winds start fading, and if anything, you get westerly winds in the West Pacific. That sort of smells like the active phase of the MJO. All right? Anomalies, differences from normal for this time of year. Yeah, you see all this, and it's kind of hard to tell. This puts it into a seasonal, historical kind of perspective. And you see, yeah, the trades here are maybe slightly stronger than normal in the east, but not much. But what you really take notice of here is much stronger from the west than normal in this area. That's a sure sign of the active phase of the MJO. The active phase of the MJO, basically, if it's strong enough, you get what they call a westerly wind burst, and trades reverse direction in this area, and that's exactly what's happening here. Good signs of a strong active phase of the MJO, and that is good for feeding El Nino. Okay, so this chart is wind anomalies over the past 5 days up at the 850 millibar level. It's about 4,700 feet up, but a good proxy for what's going on at the surface. There's the equator. There's South America. Galapagos are right there. New Guinea's right there. The oranges are westerly anomalies, but we're only interested in what we call the Kelvin wave generation area. This area from 135 west, like right here, 5 degrees north and south of the equator over to about 170. If you get west winds in here, west anomalies, and they last long enough and strong enough, then you can actually get what's known as a Kelvin wave. That is, these west winds take warm water that's all in these islands in the maritime continent right here around the equator, start pushing them off to the east, but not on the surface. They fall into a bubble of warm water below the ocean surface. They traverse the whole way across the equator, and then that's what's called a Kelvin wave. That Kelvin wave can erupt along Peru, Colombia, Ecuador area right here, and start forming a warm slick pool of warm water on the ocean surface, and the trades will carry it off to the west. And this, if you get enough of these, this looks like it might be the start of Kelvin wave number 4, and just in time. The 4th in the past since last February. So in a year, let's say a year and a half, the 4th one in a year, and this is what's helping to feed El Nino. So that was on the 6th of May, the 7th. You get the idea here. West wind, pretty strong west winds right on the equator. It looks perfect for generating Kelvin wave. All right, let's go take a look at the forecast and a little bit more historical. All right, zonal wind anomalies. Okay, so this is a weird chart. Whole planet on one chart, okay? Wraps the whole way around the globe. But what we care about is Pacific Ocean. Well, there's the date line, 180. California's at 120 roughly. So the Pacific Ocean is from about here. The New Guinea's right about there. So between all that, but the Kelvin wave generation area, the one we're really interested in because we want to see west winds making Kelvin waves to feed El Nino, is between about here and here. And then you just go right up over time. So we see blue, that's easterly anomalies. That'd be like the inactive phase, the MJO. But then starting about the beginning of May, you see westerly anomalies started building, and they started moving off to the west. They peaked maybe 2 days ago, 2 days to a week ago, right in the core of the Kelvin wave generation area, and they're supposed to hold for another 4 or 5 days, and then start moderating. So this looks pretty good. I mean, it's not the best west wind active MJO pattern we've ever seen in terms of supporting Kelvin wave development, but not bad. Other point to note, so this is the active phase of the MJO, and if you draw a line through it in your mind's eye, right on out to here, California is right here, right? See that westerly anomalies, and that is 5-7 days out. And what's supposed to happen a week from now? Rain into California, snow in the Sierra, all driven by what we speculate is the active phase of the MJO pushing due south of California on the equator. And that's what the active phase is known for, is wherever it is, north or south of there, that's where you get active weather. And the inactive phase does just the opposite, sort of builds in high pressure. So the rain and snow forecast, probably attributable to the active phase of the MJO pushing south of California on the equator. Good, interesting correlation. All right, so let's look a little further out. So this is outgoing long-wave radiation. Another way, it's a model of sunlight reflectivity off the ocean surface. Blues are negative anomalies, meaning clouds, meaning the active phase of the MJO. So the MJO has a wind component, has a cloud component. Basically, the active phase of the MJO is like a big trough of low pressure that goes from west to east on the equator across the Pacific. It actually goes the whole way around the planet, but the Pacific's the part we really care about. And this red stuff here, positive anomalies, meaning high pressure, meaning the inactive phase of the MJO. All right, so we'll call it a modest active phase of the MJO today in the far west Pacific. Oh, that's right. There's New Guinea. There's the equator. That was South America. That little dot there, that's the Galapagos. So active phase, and this is in 5-day increments. So good for about another 5 days, and then it starts fading, and here comes the inactive phase. This is 2 weeks out, okay? And the active phase, you see, moving slowly off to the east, pieces of it trying to organize south of California, probably a week out somewhere in there, maybe, if you can. So this is the statistic model, if I could say it there. And here is the dynamic model, the GEFS model. It's saying basically the same thing, but the inactive phase that's supposed to follow, in fact, you can see there versus there, not as strong, but still moving in. So if there's ever a shot for swell production, it's over the next week. So, and we know there's swell in the water now, so take what you can get, and there's possibly more coming, both north and south, so not a bad pattern. But after that, looks like inactive phase to set up, and that will definitely put a damper on storm production and therefore swell production, and probably set us up for more wind swell off California at that point in time. Phase diagram charts, just another way to look at the MJO. Assume you're looking down this circle. Assume that's the North Pole. You're looking down on it from straight up above on top of our planet. The MJO moves from west to east, from the West Pacific over the Atlantic, and then over North Africa into the Indian Ocean, then over the maritime continent, and round and round she goes. The further away, the heavy dot is where the active phase of the MJO is, so in the West Pacific right now, the further away from this circle it is, the stronger, so modest. If it was up here, it'd be really strong. And these are the different forecast tracks for it. Basically, the statistic model suggests, moving out of the Pacific over the next 2 weeks and into probably the Atlantic. The GEFS model, basically saying the same thing. So the models are all in pretty good agreement at this point in time. Let's go even further out. This is the 40-day model. This is potential for precipitation at jet stream level. Green's favorable precipitation. And this shows about a week ahead of what's really happening down at the surface. Jet stream sort of leads the charge, and then what goes on the surface drags a little bit behind. So active phase, green favorable for precipitation. Active phase moving out and into Central America, let's say the end of May. Stronger inactive phase per this. We think this is a statistic model, and that is to traverse the Pacific starting later in May, the whole way through, let's say maybe June 10th or so. But then starting about June 5th or 6th in the West Pacific, here comes another active phase, and it does its thing, traversing the Pacific. So you see active, inactive, active, and traversing the equatorial Pacific. So it's a regular, steady pattern. So here's something to take note of. So this is one of these charts again, whole planet on one chart, Kelvin wave generation area between these two, this area here. We're going back in time. This is, here we go, February. That was a strong westerly wind burst that created a Kelvin wave, and we'll get into the discussion of that Kelvin wave in a minute, but that Kelvin wave is currently erupting, pretty much done its thing off of Ecuador right now. Then we've gone through March and April with nothing really, and now here is the heavy contours are the active phase of the MJO. The reds and oranges are westerly anomalies, and this is already stuff that has happened, weather that has happened. Strong westerly wind burst currently happening, expected, and you can see it moving from west to east across the Pacific. Here we are a week from now, okay? Active phase still in control, but moving east, and California is like right here. This is right about a week out or so, a week and a couple of days when all the weather's supposed to move into California, all driven by the active phase of the MJO, all across all these different models. It all syncs up pretty well. Now, the interesting part is active phase moves out as we get into late May, but notice this, westerly anomalies continue on the dateline in the Kelvin wave generation area, even though there is a weak inactive phase that's supposed to be in play at that time. Why is that? Well, let's go take a look at one more model. All right, so here we go. Yet another one of these, all the planet on one chart. Here's the Kelvin wave generation area between these two technomarks. Now, this is past history down here, the forecast here going at the top. Notice back in February, here's our oranges and yellows again. Big westerly wind burst. Here's, according to this version of the model now, not as strong as that one, but still, westerly wind burst of some degree occurring. We'll overlay the MJO. The solid contour is the active phase of the MJO, and that is still to be occurring into, let's say, May 22nd or so on the date line. And then the dotted contour is inactive phase of the MJO, but notice westerly anomalies continuing and retrograding west some. Then another active phase of the MJO, maybe in the late June, pretty much the whole month of July, with more westerly anomalies. So why is that? Well, let's overlay. Why are there westerly anomalies even when the inactive phase of the MJO is occurring? We overlay the low-pass filter. So this is sort of saying, when you see solid contours, that's where we'll call it a low-pressure bias is. When you see the dotted contours, that's where a high-pressure bias is. This is in the Indian Ocean. This is right over the date line. Boom, 180 degrees, that's the date line. And 1, 2, 3 contours, 2 contours. This is what a weak El Nino looks like on this kind of a chart. But notice, we go from 2 contours down to 1 contour as we get into July. It smells of a fading El Nino pattern as we get deeper into summer, but still not gone, with westerly anomalies still in play. All right, subsurface temperature anomalies. So let's go see what's going on in the ocean. West Pacific here, East Pacific here. These X's are sensors on the TAO buoy array on the anchor lines of the buoys strung across the entire Pacific on the equator, and then we use a model to sort of fill in the gaps. We see 29 degree Celsius temperatures to 160 west. That's actually moving pretty far off to the west. The 28 degree isotherm, it was actually the whole way into Ecuador last week, I believe, or close to it, maybe around 115. It's retrograding now at about 127 west, suggesting that there was a Kelvin wave, but it's fading. And then the 24 degree isotherm line pushing into Ecuador. Let's go look at anomalies, differences from normal for this time of year. We see a steady, there's the 0 degree line, plus 1 degree, plus 2 degree anomalies filling the entire Pacific Ocean. So not only is there warmer than normal water in the west, but it's also in the east and even stronger here. This is a Kelvin wave. This is Kelvin wave number 3 erupting right now in the East Pacific. Not super strong anymore. It looked a lot stronger. Of some concern is these cooler anomalies down here, and we're almost wondering if there isn't another Kelvin wave that develops that almost smells like some sort of La Nina. If you see cool anomalies building in this area, then that is definitely, and they persist and they're over like a broad area like that, that smells of La Nina. Here's another model, same sort of deal. Warm anomalies. Oh, look at this right here. This wasn't here last week. So we know westerly anomalies. This is the West Pacific here, East Pacific here. Same deal. You're going down depth, down 100 meters, 150 meters. We have warm anomalies from about 110 meters on up, filling the Pacific. Kelvin wave number 3 erupting here. Still follow on warm water here, and it looks like more warm water is starting to get pushed off the maritime continent in association with what we know to be west anomalies occurring there. So maybe Kelvin wave number 4 is trying to organize. Then our historical chart, upper ocean heat anomalies. This is going back in time. West Pacific here, East Pacific here. You can actually see the Kelvin waves. This is Kelvin wave number 1 here, traversing, started like February of last year, traversing into the East Pacific in the June-ish, July time frame. Kelvin wave number 2 developed from a strong westerly wind burst in the West Pacific in the September timeframe. You see the warm anomalies working their way across into Christmas, into Ecuador. This is Kelvin wave number 3 right now. It's erupting, almost gone according to this, in the East Pacific. We see some cool anomalies building here, not nearly as much warm water as there was in this time frame, a year ago. Meaning the West Pacific is probably pretty much tapped out of warm water. If we get another Kelvin wave, this is probably going to be the end of the Kelvin wave cycle, and then that would usher us into some sort of La Nina maybe. Hopefully just a soft landing and just neutral or weakly cool temperatures, if at all. But we know we have west anomalies blowing now. If they build a Kelvin wave, it'll take 3 months plus for that Kelvin wave to make it across the Pacific. So we're, May, June, July, August. So maybe another Kelvin wave erupting in the August-September time frame. Then after that, temperatures probably fading in the Pacific. Now, remember, the atmosphere takes at least 3 months after the temperatures fade to do anything. So we'd be deep into winter before the atmosphere and the jet stream and all that would start to notice any change in what's going on in the ocean, therefore suggesting that at least the fall and the earlier part of winter will look probably similar to what it looked like last year. Reasonable, nothing great, but, a little bit enhanced chance for storm production, swell production in the North Pacific. Right now, with El Nino in play, we're more interested in what it's doing for the southern hemi right now. But still, we think we're going to have a decent pattern, at least into December, early January-ish time frame in the North Pacific. All right, sea surface temperatures. So what are we looking at here? Well, this is sea surface temperature anomalies, differences from normal for this time of year. There's Peru, there's Ecuador, there's Colombia, Galapagos there. Here's the equator. We see, warm anomalies associated with our Kelvin wave erupting, but nothing like, grabbing your eyeball going, wow, it's really happening. If anything, we see most of the eruption seems to be happening from about 120 west and out from there. And the thought is this El Nino is not a east-focused El Nino. That's only in the strongest El Ninos. This is more like a Modoki El Nino, which tends to have the eruption point more south of California, south of Hawaii, that area. And that's certainly what this pattern, and the pattern has looked like the entire year. We just have not seen strong, sustained warming in this area at all. So this is what they call the Nino 1.2 region, right in here. It's sort of the, you look at it, and it's really noisy, but if you see really spiking temperatures here and they stay for a long time, that's a sign of a strong El Nino. We've not seen any of that. All our warming's been out here in what they call the Nino 3.4 region, from 5 degrees north to 5 degrees south, from 120 west right here out to 170. Draw a box right there. It's the official El Nino monitoring region. Yeah, we have enhanced temperatures, but nothing huge, nothing, particularly exciting. And then the trend, just the past 7 days, see this blue that's cooling from the Galapagos out to about 140 west. That patch is actually built, and we actually see some cooling down off of Peru, which tells us that Kelvin wave number 3 is probably fading. Doesn't mean it's getting cold there, it just means it's not as warm as it was. And most of the warming is out in this area from 140 out to 160. There's Hawaii right there. So this again supports that Modoki El Nino kind of pattern. And then here, of course, is the actual sea surface temperature anomalies as of right now. And you see the whole Pacific warmer than normal, but not blazing warm. We're talking, half to 1 degree, maybe pockets of 1.5 degrees here and there, with the focus of the warming here and then sort of north of the equator. Main El Nino monitoring region right here, out to 170 right there, and so it's warmer than, and then that Nino 1.2 region right here. If it was cooking, then we'd be in a major El Nino, but it's not. Let's put numbers in context, historical context. The Nino 1.2 index. This is for that whole area, the average temperatures. You can see they've been toggling either side of dead neutral. Today we're at 0.602, 0.6 of a degree above normal. But I'm not seeing anything here that suggests it was ever really warm for more than a week or so, and then cold for a week or so. Just bounce on. Basically, if you draw a trend line through it, pretty much dead neutral the entire time. So not a strong El Nino. Now the Nino 3.4 area, the official El Nino monitoring region, but really at this point it seems like it's more a good area for monitoring Modoki El Ninos. Today's value right there, 0.464, which is about a little less than what it's been. It looks like it's since the end of February, it's been hovering around 6 or 0.65, 0.65 of a degree above normal, something like that. But, warmer, but nothing cooking at all. Very weak El Nino suggested. So, are these temperatures having we've talked MJOs and westerly wind bursts and Kelvin waves erupting off of Ecuador, creating warm pools of water which tend to be displaced more in the central Pacific than off of Colombia and that area. And what effect is this having on the atmosphere? All right, so there's the Southern Oscillation Index, and this is the only index we're going to talk about because the other index just hadn't been updated and we don't know what's going on there. But anyway, as of May 12th, so this is the difference in pressure between Darwin, Australia, and Tahiti. When Tahiti pressure is lower, typically associated with warm water building on the on the equator. In the Pacific, then you get a negative daily contribution. Today, minus 21.74, all totally attributable. You see it's only gone on for 1, 2, 3, 4, 5, 6, a week, attributable to the active phase of the MJO. But then you look at the 30-day average, you average the past 30-day measurements. See, that was probably another active phase of the MJO, and then it went neutral or inactive, and now it's going active again. Right now, minus 6.81, and that is better than what it's been for a month, suggesting a stronger active phase of the MJO. The 90-day average, minus 7.87, and it's been hovering there, for quite a while now. It's actually getting lower. If this was down around 12, 13, or 15, then I'd say you're having a pretty strong El Nino. This suggests, we'll call it bare minimal El Nino. So here's the 30-day SOI charted out since January of what is that, 2 years ago? January 17 to 18 to 19, 2.5 years. You'd see here when it's positive, it's La Nina, and generally it was positive during 2017, the fall of 2017, and then somewhere around spring of 2018, you see the trend line is going down. When you have these big drops like that, that's the active phase of the MJO. So basically what you're saying is to get into El Nino, the active phase needs to be stronger than the inactive phase. You see big drop, there's your inactive, big drop, there's your inactive, active, big inactive, bigger active. You get the idea. So it looks like we're in some sort of El Nino, but not strong, because the average you'd want to see down around 15, 10 or 15 or more, and generally we're toggling somewhere down here around 5 or something like that. So weak El Nino in play. All right, so let's put all this together in one package. What do we have? We have southern hemi swell in the water right now. We have another stronger southern hemi swell on its way. Actually, I think it's starting to hit Hawaii now and expected into California for the balance of next week. And then after that, well, maybe a bit of a break while the southern hemi reorganize, but the models are suggesting, hey, we could be back in a good pattern a week from now. But in the meantime, North Pacific, theoretically, as the active phase of the MJO moves east, is supposed to reactivate. Maybe a little bit of swell coming from the Gulf of Alaska by next weekend or so. Probably short-lived, and a little bit of rain and maybe a little bit of snow. Then after that, well, hard to say, but the general consensus is southern hemi probably staying pretty active, being fed by a weak El Nino, and, mainly focused during the times of the active phase of the MJO. So maybe a bit of a break here as we get later into May, but then sometime mid-June or so, things might wake up again. And then still decent pattern continuing through summer, into the fall, into the early winter, and then maybe things might start falling apart. So the short message here is take it while you can get it. Never look, what is it? I don't know what the saying is, but when you got it in your hand, take it. And that's what it looks like we're heading towards. All right, so that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.